Hello, this is Rakesh Rao from DesignSense Software Technologies, Bangalore. In this GeoTools video running on ZWCAD 2025 Standard Edition, I will show you a command which you can use to clean up your drawing and build topology. It is called Lineworks Intersection Processor, and you can type it on the command line with the command gt_intex. The Lineworks intersection command helps to clean up intersections like this. So for example, if you have a number of lines which are crisscrossing each other, which is a typical case in utilities drawing, telecom networks, pipeline networks, sewer and so on, you can process them, and suppose you want to break them at their intersections, or you want to add a vertex at every intersection. So all those kind of operations can be done with this command. It's available on the ribbon as well. So if you come here to the drawing cleanup menu here, so you can find Lineworks intersection here also. So we go here to Lineworks intersection, and then now there are two parameter sets here which you need to understand. The first one is the object break option, and the second one is the vertex add option. The object break option controls whether the objects should be broken into two separate entities at their intersection or not, and they work on source objects and target objects. So in a minute I'm going to tell you what is a source object and what is a target object. Under vertex add options, again there are options to suggest whether the vertex addition must happen on the source objects or on the target objects, or on both source and target. So for the moment, let us switch off this option. We don't want to break any objects, and we will just keep this vertex add option on for the source objects. So I'm going to select now my source object. So from this button I'm going to select this particular polyline as my source object, and for target objects there are two conditions here, same as source or select manually. So I'm going to say select manually, and I'm going to select this as my target object. So you can see now that target object and source objects have been selected with two different entities, and we have chosen the vertex add for source objects only. So I'm going to say OK now. Now you can see that in the source object there has been a vertex added exactly at the intersection with the target object. So if you notice, this was the target object, this was the source object, and we have a vertex exactly at the intersection, and this is not broken, which means it is still a single line. So this means that the command has performed as per the settings. Now let's choose another option. Now in vertex add I'm going to say both source and target, and once again I'm going to select my source. Now the second line I'm picking, this is my target, say OK. So now if you see, again there are no break options, so the source vertex has been added, and if you choose the target polyline, you can see that it has added a vertex on the target also. So that is how the source and target vertex add option works. Now let's look at the break option again on the same data. This is just a copy of the same. So I come back here to Lineworks intersection processor, and I'm going to choose this source object break, and let us see how it works. So once you say object break, the vertex add option is not relevant, because when you break the object anyway a vertex is created, so there is no point in specifying separately whether you want a vertex add or not. So this becomes irrelevant now, so I might as well leave it at none. That's my source, and that's my target. You can see that the source object has been broken into two separate entities at the intersection, and the target object is as it is. So this is how you can run the command. So this is a very useful command for anyone who is in surveying, mapping and wants to create clean topology, especially those who are in the pipeline industry, sewer and water pipelines, or even telecom pipelines and so on. So it helps you to build topologically correct data where you need a vertex at every intersection, or you want the polyline or the network to be broken into correct differentiated paths. We did it on a small sample here, but you can do it on the complete data set also. It may take a few minutes or maybe even longer depending on your data set. So I'm not going to run it on this. For example, if I run it on this, it will take about 2 or 3 minutes to process. So if you have very large data sets, I recommend that you split your drawing into smaller portions and run it in small pieces, so that will be easier to manage. Thank you for watching this video, and do let me know if you have any questions.